Hey, welcome back to some quarantine notes. This week we are continuing our work on polynomials, but now we're gonna just focus this week on distributive property. So that's our title today. Distributive property. Now I'm crossing my fingers that this is a review. We've done it in my class. I know we have. You've probably started learning it actually in 7th grade. So hopefully this will feel comfortable. We are going to add layers of complexity to this, just with variables and powers and things like that. So we're going to start off just kind of basic though. So first thing, I want you to kind of tell yourself, this is a note to yourself. I want you to say, we always need to follow, we always need to follow the order of operations. So in mathematics, we always need to follow the order of operations. Do you remember what that is? Do you remember another phrase? People go, oh, is that PEMDAS? Do you remember learning this? So order tells us the order we have to solve a problem when simplifying or solving. So you would do P, which is parentheses. You have to deal with your parentheses first. Next, you would take care of your exponents. That's the E. Multiplication and division are kind of grouped up together. You do those from left to right. Same with addition and subtraction. That's the last thing you would take care of is addition or subtraction, and you would go left to right. So that should be ingrained in your head, okay? Now let me show you an example of just a problem we would use order of operations on. So you're gonna have a 10 next to a set of parentheses, and inside the parentheses is 3 plus 4. Now, if we follow PEMDAS, because we always follow PEMDAS, we would notice that we would have to do parentheses first. So I look what's inside my parentheses and I go, oh, 3 plus 4? What's 3 plus 4? 7. There's still going to be parentheses around that 7. And then the 10 is right next to it. Now, what does it mean when a 10 is, or a number is right next to something? It means multiplication. This is 10 times 7, which is 70. Okay? So we solved this using order of operations. But I do want you to know that there's another way you could have solved it. Okay? And I don't know who discovered this, but congrats to them, because it does help us out when we have algebra, meaning variables involved. So we're going to do the same problem, but we're going to solve it a different route. So somebody way back when discovered that you can kind of solve this sort of problem two ways. You can find the sum of the stuff in the parentheses and then find the product, or you can take the product of each of these and then take the sum. So 10 times 3 is 30. 10 times 4 is 40. And if I were to add those up, 30 plus 40, I still get 70. So we get to the same answer. Now, hopefully you're asking, Meineke, why would I do it this way if I can just do it this way quickly? Well, this sort of, words are hard right now. This sort of process, there we go, this sort of procedure is helpful when we have variables inside these parentheses, okay? But this little arrow thing and the multiplication that we did, that's called distributive property. Distributive property. Okay? So let's kind of see when we might apply that in my class. So let's say we have some parentheses here. And inside your parentheses, you have x plus 8. And right next to the set of parentheses, out front, although it could be in the back, but out front, we have a 5. Now, question you need to kind of ask yourself, should we follow order of operations? Absolutely, we always need to. So order of operations says I have to take care of parentheses first. So I'm only focused on what's inside the parentheses. But here's where you run into kind of a roadblock. X plus 8, can you add x plus 8? No, they're not like terms. So maybe make yourself a note, since these are our fancy notes. Say can't add x and 8 because they're not like terms. Okay, so that doesn't mean we gotta just, scratch out order of operations. We're still gonna follow it. And we're actually gonna use this method right here. If I can't actually simplify what's in the parentheses, since x and 8 are not like terms, then I would go to my next letter up here, which is E, exponents. I don't see any exponents. So now we go to multiplication or division. There is some secret multiplication happening in this problem. This 5 is right next to a set of parentheses, which means it's 5 times this sum inside here. So we have to do that multiplication next, which means we have to use distributive property. It's the only way to simplify this. So that number out front gets multiplied to each and every term on the inside. And distributive kind of means that if you were to distribute papers, you're handing it out to each person. Just like this 5 has to get multiplied to each term inside the parentheses. So 5 times x is 5x. 5 times positive 8 is positive 40. So we add 40. Now 5x plus 40. Can I shove those together? Can I combine those? No, they're not like terms. So that's my final answer. 5x plus 40. This is the simplest form of this multiplication right here. Now I'm gonna test you on something here. What if inside the parentheses, instead of x plus 8, we had x times 8, and then we had a 5 out front? Do you think we should still use distributive property? And the answer is no. We do not want to use distributive property. So once you cram out your little note, if you can, I'm going to say don't use, and I'm going to abbreviate DP, distributive property. Don't use distributive property because you can simplify the parentheses. If you can actually simplify what's in the parentheses, then you're not going to need to use distributive property. And inside your parentheses, you have x times 8. X times 8, I can multiply that together. X times 8 is just 8x. Then I multiply 5 times 8x, and I get 40x. So we did not need to use distributive property here because you can actually multiply whatever you want. So if there's multiplication happening inside your parentheses, you don't need distributive property. If there was division happening in there, you wouldn't need distributive property. The only times you're going to need to use distributive property is when you have the sum or difference, which means you have addition or subtraction inside the parentheses. So maybe let's make a note of that. Is just like, we'll say when and how to use distributive property. when and how to use the distributive property. So this isn't gonna be like super fancy language. I'm just gonna tell you like things to check for, things that your eyes will just visually see. Now, honestly, when I see a set of parentheses and a number out front, I immediately think distributive property, but that's not gonna work in this case. There has to be either addition or subtraction inside the parentheses. So we need to make note of that. So let's say, if there is a set of parentheses with terms being added or subtracted. So the terms inside the parentheses, really they have to be either adding or subtracting. Okay, so that's when you would use it. And then what you're gonna do, so the how, is you're going to multiply and I'm not gonna say number, like we have a number out front here. I'm not gonna say number because sometimes that can be a variable. So multiply the term that's right next to the set of parentheses So the term I'm talking about is this. It's right next to the set of parentheses, and we're going to multiply that term to each, and I'm going to capitalize that, to each of the terms inside the parentheses. Okay. And I do want you to just put one last thing here. Simplify if possible. Okay, so if you see a set of parentheses and stuff is being added or subtracted, then you think, oh, I can use distributive property here. You take the number that's out front, that's right next to the parentheses, and you multiply it through. You multiply it to each of the terms on the inside. If there were 3 terms on the inside, you would multiply it to each of them, okay? So now we're just gonna do some examples, and we're gonna start off fairly basic and then work our way up to kind of some more challenging problems. So we'll just write examples here. And I guess you should probably have kind of a set of instructions though. You're gonna do a combination of distributing and then simplifying. And what I mean by simplifying is like combining like terms. So you must distribute first, then combine like terms. Distribute first, okay, has to be first, then you get to simplify and combine your like terms. The reason why you would have to distribute first is because that follows the order of operations. Distributing is multiplication because you're multiplying it through, whereas combining like terms is your addition and subtraction. So you have to do distributive property first, and then you can combine. Okay. So we're gonna start off with kind of 3 quick examples. These should be familiar to you. So on number 1, we have a -2 in front of a set of parentheses. Inside your parentheses, you have 8x plus 3. Quickly double check that inside your parentheses, you have either addition or subtraction, which we do, okay? That means I'm going to take this number out front. Now I can't add up 8x plus 3, which is why I use this number out front. So the number out front gets multiplied to each of the terms on the inside. Negative 2 times 8x is negative 16x. Negative 2 times positive 3 is negative 6. So here's what I'm left with, negative 16x minus 6. Now, can I simplify this further? Can I combine like terms? Well, there's no like terms to combine here. These are not like terms. They don't have the same variable. So I'm done. That's it. Number 2. Now, number 2, in front of the parentheses is just a negative sign. Just a negative sign. Inside you have 10w minus 4. So I just have a negative out front. What do I do? Well, you might remember that there's like a secret 1 right there. So you're distributing a negative 1 to both of the terms on the inside. Negative 1 times 10w is negative 10w. Negative 1 times negative 4, got to keep that symbol in front of it, okay? Negative 1 times negative 4 is positive 4, so we write plus 4. These are not like terms, so I'm done. Okay, now let's say we have something with a variable out front. Let's put 7y out front. And on the inside of your parentheses, write 3y plus 2. Okay, I can't simplify what's inside the parentheses, so I have to use this number out front, this term out front. And I multiply. Here we go. 7y times 3y. Got to be so careful with your powers here. What I do is I just multiply the coefficients. 7 times 3 is 21. And then I say y times y. What's y times y? It's y squared. So that right there is 21y squared. 7y times positive 2 is positive 14y. These have the same variable, but they're not raised to the same power, so they're not like terms. I'm done. Okay, so hopefully that was fine. If it's going too quick, you might want to rewind it, but this is pure review. It really is. So now we're going to kick it up a notch, okay? We're going to go a little bit more in depth here. So I have a 3x right next to a set of parentheses. Inside your parentheses is 2x minus 4, but you're not done. After all of this, you're going to add 10x squared. Okay, so where do we start? Well, we start with distributive property. Is there somewhere where I would use distributive property? Yeah, parentheses. They're glaring at me right now. Parentheses, I can't solve what's inside of them. I can't simplify that, 2x minus 4. So I'm relying on something right next to the parentheses. Now you might have something being times after it. That is possible. A lot of times it's out front though. And in this case, it's out front. So we're going to distribute the 3x to the 2x and the negative 4. 3x times 2x is 6x squared. 3x times negative 4 is negative 12x. Now I'm just going to drop this down. A lot of kids might go, oh wait, do we have to distribute to the 10x squared? No. Why would we not distribute to the 10x squared? Ask yourself that. Why would we not distribute to the 10x squared? And the answer to that is it's not inside the parentheses. Okay, so we simply just drop it down. Now, I got a lot of stuff here, so I'm always going to check if I need to combine any like terms. And I do have like terms. They all have x's, but only these two have the same powers right here. So I can combine 6x squared with 10x squared. They're both positive. Altogether, that's 16x squared. And this negative 12x gets dropped down. I can't put those together. They're not to the same power. And another thing you should triple check is that this is in standard form. From here on out, all of your polynomials should be written in standard form, which it is, highest degree to lowest degree. Okay, next up, 8 minus 5, but that 5 is right next to a set of parentheses. Inside your parentheses, you have 3w minus 4. And after that, you're going to subtract w. Okay, so do we see any distributive property? Right here. Now, this is where you have to be so extremely careful. Am I going to be distributing a 5? Or is it technically a negative 5? And the answer is negative 5. Now, another thing, I kind of went ahead of myself. A lot of you might have went like this. Oh, 8 minus 5, that's 3. Maybe you thought you were going to distribute a 3. Absolutely not. We cannot subtract, which is way at the end of order of operations, before you actually do your multiplication, which in this case is distributive property. So you have to do distributive property first if it's there. So this is a negative 5. Got to keep that in mind. Negative 5 times 3w is negative 15w. Negative 5 times negative 4 is positive 20. Now I'm just going to drop down anything that was unused. And now I see if I can combine any like terms. So you can start wherever you want. I'm just going to start with the 8. The 8 doesn't have a variable, so it's a constant, and it can be combined with the 20. 8 plus 20 is 28. Negative 15w can be combined with the negative w. Remember, there's like a 1 right there. Negative 15 minus 1 is negative 16. So that'd be negative 16w. Now, is this our final answer? Almost. It's not in standard form. So to put this in standard form, you need highest degree to lowest. The negative 16w needs to come out front. Positive 28 goes in the back. So our final answer is negative 16w plus 28. 6 and 7. Okay. Here's number 6. We're at the point where I really do want you to challenge yourself and pause the video, try and solve it before I go over it, okay? 3x right next to a set of parentheses. Inside your parentheses, you have 4x cubed minus 2y. Okay. So I just want to make sure we are clear with how to like multiply powers through. It's easy to make a mistake. So here we go. The 3x is going to get multiplied to both of those terms. So 3x times 4x cubed. First multiply your coefficients. 3 times 4 is 12. And then I have x times x cubed. When you're multiplying variables with the same base, you add the exponents. There's a 1 here and a 3 there, so that'd be x to the 4th, 12x to the 4th. Now I multiply it to this negative 2y. Well, 3 times negative 2 is negative 6. What's x times y? Well, it's just xy. And that's it. That would be my final answer. I can't combine them. They're not like terms. They don't have the same variables. So that's it. I'm done. Okay. Number 7, this is a really good problem. You might see one on your test. It's a tricky one. I'm kind of trying to trick you. I know that's mean, but I want you to be on the lookout. So we have 2 minus, and then you have a set of parentheses, 3x plus 6. Outside of the parentheses, you're going to add 10x. Pause the video, try it out. Okay, a common mistake, and if you made this mistake, pause it, retry it, okay? A common mistake is kids would go, okay, I see the parentheses, and the number out front is this 2. No, the 2 is not right next to the parentheses. It's like over here. So you know what's right next to the parentheses? A secret 1. And in this case, it's a -1. You have to distribute a -1 throughout the parentheses. So if you made that error, pause it, redo it, okay? -1 times 3x is -3x. -1 times +6 is -6. Drop down anything that wasn't used. And now we combine like terms. I'm going to start with combining my x's because I know they have to go out front anyways for standard form. -3x plus 10x is positive 7x. 2 minus 6 is -4. Final answer, 7x minus 4. Okay, we have one more problem, and this is your go big or go home problem. If you can do this, you can do anything. It's ginormous, by the way. Okay, let's start off with it 8x minus 3. That 3 is right next to a set of parentheses. Inside the parentheses, you have 4x minus 10. We're not done. Double check you wrote that correctly though. After that, you're going to subtract a set of parentheses. Inside the second set of parentheses is x plus 5. And after that, you're going to add 3. Like I said, if you can do this, you can do anything. Okay, you have 2 sets of parentheses, which means you have double distributive property. Be very careful. 3 is not going to be multiplied. It's a -3. So we're going to multiply that -3. So we'll do that now. -3 times 4x is -12x. -3 times -10 is +30. So I've dealt with that set of distributive property. So this little 8x is going to just be dropped down. But now as I go through here, remember this whole thing? This is a -1, a secret -1 that we have to multiply through. -1 times x is -x, or -1x if you want to do that. -1 times +5 is -5. This 3, I'm not going to distribute to the 3 because it's not in parentheses. So I just drop it down. So what you did is you just did double distributive property, dropped the other stuff down, and now we're going to go through and combine any like terms. So I'm going to start with my x's. 8x minus 12x is -4x, but I still have to subtract this x. So -4x minus 1x is -5x. +30 minus 5, that's 25. 25 plus 3, 28. Final answer, -5x plus 28. All of this garbage simplified down to -5x plus 28. Pretty dang cool if you ask me. That's going to be it. Thanks for watching, guys. See ya.